Hi algebra students, make sure that you have your notes on Scatterplots, your packet in front of you. We're going to jump in by looking at two examples of Scatterplots. The first one is a Scatterplot that compares student height and weight. Weight along the x-axis, height along the y-axis. So with that, if you look at the definition at the top, a scatterplot is a graph consisting of, it should say data points. It measures and compares two quantities together, two sets of data. If there's a relationship between the two variables, the line of best fit shows the correlation. And we're going to use a lot of what you learned in Chapter 8 to write the equation for that line. The correlation can be any of these 5 types. It can be positive or negative, and that just is based on if you drew a line down the center of the data, a line of best fit, does it have a positive or a negative slope? If it's positive, it has a positive correlation, and if it's negative, it has a negative correlation. And then you'll also see some of the points are closer to the line of best fit, and that makes the correlation strong. So in this first example, we've got a strong positive. It's got a positive slope, and the points are very close to the line of best fit. If it is increasing and it has a positive slope, but the points are very far away from the line, we call that a weak positive correlation. Same thing with strong. Same thing with negative. You can have a strong negative correlation, or you can have a weak negative where they're further from the line. There are some data points that don't have anything to do with each other, and we'll look at that further in this packet. So when there is no line of best fit that you can really draw, they're all not really going up, and they're all not really going down. This we call no correlation. So when we look at the graph for number 1, we want to determine what kind of correlation they have. The points are all very, very close to each other. They're all going in, if we were to draw a line of best fit, they're all going very close to a line that has a positive slope. So we would call this a strong positive correlation. For number 2, we're looking at the relationship between age and height. This would have probably a line that goes something like that, but see how the points are all spread out and they're not really going in one direction. You could kind of argue that a line could also be down here. So for this one, we would say there is no correlation. For example number 4, we're looking at the number of customers and the temperature of an ice cream store. So we could say that there is a weak positive correlation here. The points are not very close to the line of best fit, but we do see an upward trend, which kind of makes sense because more people want ice cream when it's hot outside rather than cold. So if we take a look at number 5, we're collecting data on the income of 10 families, so how much money they bring home, and the last 4 digits of their phone numbers. If you think about your house phone number, if you still have one, was the house phone number set on how much money your parents make? No, it's a random line, or a random number. So when we look at these graphs, there should be one that has no correlation, and that would be letter B, because your phone number does not depend on how much you make. So the correct answer here would be B, and the reason is because this shows a graph with no correlation, because again, income and phone numbers are not linked. So we're going to take a look at an example where you write an equation for the line of best fit. And the line of best fit has already been drawn for you in blue, or it's on the screen in blue. So you want to find the relationship between the amount of cups of coffee Mr. Gajeki drinks and the number of hours he sleeps. The more cups of coffee he drinks, the fewer hours he sleeps. So before we even do any algebraic work, I want you to take a look at the line and figure out some things that you can point out about the line. First of all, let's take a look at the direction of the line. The direction of the line is downward, which means that we need a negative slope. So when we're looking at our options underneath, there's one equation that has a positive slope in front of the x. So we can already eliminate choice B because we know that our slope has got to be negative instead of positive. The next thing I want you to take a look at is I want you to take a look at where it crosses the y-axis. So what is the y-intercept? Well, it's about I would say maybe 5.75. So what you want to do is you want to take a look at the given choices and think about what could we eliminate as not a good estimate. And that would be choice C, because we are nowhere near 1 for the y-intercept, because 1 would be down here. Now what we're going to do, since we've narrowed it down to 2 choices, which is much, much better, and if you can do that on the Keystone or the PSSA, you want to do that. You want to eliminate as many choices as possible so that your odds of getting the choice correct, even if you're a little stuck, are better. So let's take a look at the line of best fit a little bit more closely. You want to find 2 points on the line that you could write an ordered pair for and use in the slope calculation. But with this line, a lot of the points are above it, and you can't use a point that does not fall exactly on the line, so we couldn't use that one. So what you want to do is you want to find 2 points, and you probably want to work as intelligently as possible and find 2 points that fall neatly on the line and have some nice x and y coordinates, because if I choose this point right here, which falls nicely on the line, that's at about 6.6 for the x coordinate, and it doesn't fall neatly on the y-axis either. That's a little bit high. So we would be looking at a x and y of about 6.6 and 2.25, and we don't want to use decimals if we can avoid them. So 2 points that I found on the line would be at 5 for the x coordinate. If you kind of draw a straight line up, that also has a y coordinate of 3. Now you'll notice there wasn't a point there to begin, and that's okay because it's still a point that falls on our line of best fit. So we're going to use the coordinate 5, 3 as one of our ordered pairs. Another one that falls nicely on the grid lines with pretty x and y values, you could say, is 3 for x and 4 for y. So 3, 4 is another ordered pair that we could use there. So what I'm going to have you do is I'm going to have you find the slope of those 2 points. So you should be finding that the slope is -1/2. And if you take a look at your slopes for the remaining choices, one is at -2/5x and one is at -20. So we can pretty much assume that we know the best fit line at this point, because for choice D, the slope of -20 is super, super different from our slope of -1/2. And if you take a calculator and you divide -2 by 5, you're going to get about, or equal to, -0.4. And -0.4 is very close to the decimal of 0.5. So those two are pretty close. And you'll find that your equation for the line of best fit will be different from other students around you just because it depends on the points that you pick. And so don't get caught up on the fact that you didn't find the exact slope to match, but you know that it should be in the ballpark. Now, I didn't ask you to go ahead and find the y-intercept, but you should feel comfortable doing that using an ordered pair and the slope to find b. So go ahead and find b. So whether you use the ordered pair 3, 4 like I did, or if you go back to the ordered pair 5, 3, you're going to plug that in for x and y, solve for b. I found b to be 11 halves or 5.5, which, if you look at your choice A, which we think is the answer, 5.5 is very close to 6. So we're going to select A as our correct answer. So we're going to take a look at a scatter plot for number 7 that shows a student's GPA in relation to the number of hours they spent playing video games. You need to draw a best fit line, and I did that on my screen already. And you'll notice that I tried to go down through the center of the data and have the same number of points above and the same number of points below. And when I did that, I didn't really go through many of the data points in the graph. And you want to use a straight edge, so yours should look a lot better than mine, drawing it with the paper and the pencil. But I did go through 2 points that I can use relatively easily to find the slope. I went through 5, 0.5, so that point I went through, and I also went nicely through 2, 3. So I'm going to use that ordered pair as well. But let's not get ahead of ourselves. There are a couple that we can eliminate right away. If you take a look at the list of options there, our line has a negative slope. So we can automatically eliminate choice C because that has a positive slope. The other thing that we can do is we can look at the y-intercept. Now, depending on how you drew your line, you should be somewhere probably in the ballpark of between 4 and 5 for your y-intercept. If you look at the y-intercepts here, we have a lot that are vastly different than that. It looks like we can eliminate choice A. It looks like we can eliminate choice D. And it looks like our option should be B. But let's go ahead and check that anyway. So let's use the 2 ordered pairs and find the slope. So I've got 2, 3. And 5, 0.5. So I'm going to use my slope formula to find the slope. So finding the slope here, I'm going to get negative 2.5 divided by 3. I'm going to use my calculator and the fraction abilities on my calculator to translate that to the fraction negative 5 over 6. If you got a decimal, you probably got negative 0.83 repeating. So you want to just hit your arrow F or your F to D button to change that to a fraction. And if you don't know where that button is on your calculator, please ask your math teacher because we can help you out on that. So our slope is negative 5 over 6, which is very close to negative 1. So B is looking better and better. Now I want to find the y-intercept. So finding the y-intercept, I used the ordered pair 2, 3 and avoided that decimal for the second ordered pair. I got an answer of 14/3, which is about 4.7. So if we look at our options there, B does look like it is the best match because it has a y-intercept of 5, which is very close to 4.7, and a slope of negative 1, which is very close to negative 5 over 6. On the next example, what we want to do is design a scatter plot based on the data for ice cream versus temperature. And they tell you that the x-axis should be 2 degrees per block. So that means temperature is going to be along the x-axis. So you're going to want to draw in your axes. And we're going to need a label. This is temperature. In degrees Celsius. And then our y-axis will be ice cream sales in dollars. Next, you're going to count by the 2 degrees per block for the x-axis and label. I skipped every other block, so I just labeled by 4. And then $50 per block, so I counted by hundreds on your y-axis. And then you want to go ahead and plot those points. And so there's my 12 data values, and then what I want to do is I want to draw a line of best fit down the center. So looking at the options, there's some things that I can already figure out will not work. So my equation, my line of best fit, my equation is going to have a positive slope. So I'm going to eliminate choice B because that has a negative slope. The other thing that I'm looking at is the y-intercept on A doesn't seem to fit, because even if I drew my line a little bit differently, and yours will be different, I'm not crossing anywhere near 150 for the y-intercept. So I'm going to go ahead and eliminate choice A as well. Now to find the slope, I need to pick 2 points on the line. And I'm going to pick things that it went through very nicely. For instance, it looks like it goes through this ordered pair at 16 for the x and 350 for the y. 16, 350. And another one that looks to be decent would be maybe 30 for the x, and that looks to be halfway. So 30, comma, 675. So let's find the slope between those two ordered pairs. So I'm finding that the slope is about 325 over 14, which is about 23.2, and that's closer to the 20 than it is to the 30 for the slope for D. And the last thing I want to do is find the y-intercept and make sure that's in the ballpark of negative 41. So I'm finding a y-intercept, it's kind of gross, but I'm finding a y-intercept of about 21.4, which seems to be really off from the y-intercept of the given choices, but if you think about it, negative 21 is a lot closer to negative 41 than it is to negative 200. So C seems to be the best choice here. Make sure that you bring any questions into your math teacher the following day, and make sure that you're graphing these very carefully. You want to use a straight edge for these. That's really important.